Hello everyone. I've selected a few of the problems from the 4-2 practice set that you had. Yeah, trying to use my psychic abilities to figure out which ones you had questions about. I'm guessing you have questions about number 5. Okay, one version of it here. Oh my goodness, look at how small the scale has to be on my graph. Together with the pair of points 17, 0 and 0, 17, there are 6 points that could be the third vertex of an isosceles right triangle. Find them. Well, sure, that's easy for you guys to say. The first thing I would say is let's plot those points and play connect the dots. It says that there are 6 places where we could have the third vertex. Well, isn't just coming down here to the origin and using one horizontal and one vertical segment, that would make it a right triangle. It says it's got to be isosceles. Well, this side will be 17, that side will be 17. This is an isosceles right triangle. One of the possible locations is the origin. Well, that wasn't too tough, I hope. But wait, is there a way that we could use that segment to be the hypotenuse of another isosceles right triangle right where it is? Of course. Why would he ask that question? Um, Instead of going vertically from there, how about we go horizontally from this point and vertically from that one? So that would give us another. This is 17, that's 17, that's horizontal, vertical, those are perpendicular. So that'll be at the popular 1717. Any other way that we can use this as the, no, not as the hypotenuse. Our only other option then, again, if they're telling us that it's got to be an isosceles right triangle, we've got 0, 0 using that given segment as the hypotenuse, 17, 17 as, again, still a hypotenuse. The rest of this, that segment has to be one of the legs. But wait, there's more. The length of that has to be the length of the other leg. So, yes, it becomes isosceles. But at the same time, I'm not just going to go. Now, if I could actually get this thing to cooperate. If I use my circle tool, yes, I could get another segment going off in this direction. It would be perfectly congruent to that given segment there. It would be isosceles, but if I go off in that direction, it's not going to be an isosceles right triangle as they required. So it's not just a matter of making sure that they're congruent going off in any direction. No, I have to make sure that I'm getting a congruent segment that's perpendicular. Well, actually, when you stop and think about it that way, if I just went 17 spaces straight up, and then, oh, this isn't easy to count, 17 spaces, 17 further, oh, hold on. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 spaces to the right, then I'm going to end up with a nice horizontal segment as the hypotenuse. Because if I'm making these perpendicular and congruent, that's an isosceles right triangle. So that means way out here, goodness, again, from 17, 0, I went 17 further spaces to the right. So 17 plus another 17, I hope that means 34. And then I went 17 spaces up. Yeah, not every day that you get 3417 as one of your answers. But again, hopefully you can understand here, again, it's an isosceles right triangle. Well, who says we have to go up and to the right? Couldn't we get the same exact result if we went 17 spaces straight down and then 17 spaces to the, well, gee, that one's not too tough because that ends up right there on our y-axis. This is actually the point 0, -17. And again, that'll be isosceles because I'm doing the perpendicular slope. The one's got a slope of +1, the other one has a slope of -1. They're perpendicular. Does that open the rest of them? Again, they said that there were 6 points. Well, we found 2 of them where the given segment was the hypotenuse. Who says I have to count 17 spaces up and over from this endpoint? Couldn't I do the same thing from this endpoint if I count 17 spaces down and 17 spaces to the left? That segment I've just created is congruent to the given one. There's our right angle. So here's an isosceles right triangle where this vertex is at -17, 0. And yeah, I've run out of space here. Again, if I count 17 spaces up and 17 spaces over, I'm off the chart here on this one. And I'm just going to say there's a point up here that's going to be, again, if we've counted from 0, 17, and we've gone 17 spaces to the right, that means my x coordinate is 17. And then we've gone up 17 spaces. That means the y coordinate there has to be 34. So there we have it, 34, 17, 17, 34, -17, 0, 0, -17, and then we had earlier 0, 0, and 17, 17. There's all 6 points. Draw the graph, play around with the graph. Don't be afraid to make graphs. Graphs are your friends. 15 is a popular one also because if you don't zoom in enough on that, maybe you don't realize that the front of the tent is, look at the markings there, it's an equilateral triangle where that 5-foot height, it's not big enough for me to stand up, that 5-foot height there is marked as an angle bisector. Well, if that's true, it's a multitasker. It's not only the bisector of that vertex angle, it has to be the perpendicular bisector of the base. So if we say this is x and that's x, then each side of the tent is 2x. It's at this point that they predispose that you know how to use the Pythagorean theorem. Because again, it doesn't matter, you just look at the left, you just look at the right. We have a right triangle where we are told one leg is x, another leg is 5, and again, the hypotenuse has to be segregated, separated from the rest of them. The hypotenuse is 2x. And if we use our Pythagorean theorem that the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So in this case, sure, x squared plus 25 is equal to, careful, not only square the x, but you also have to square its coefficient of 4. Combine like terms. Now things are going to get interesting because we're going to have to divide to get the variable all by itself. And then take the positive square root. Again, don't get into bad habits that are going to come back to bite you in Algebra 2. There are two possible answers. Anytime that you take the square root of both sides, you have to consider plus or minus. In our case, x represents a measurement. You can't have a tent where the length of something there is a negative 3.7 feet. So in this case, we throw out the negative. Don't do that when you get to Algebra 2. All right, so I'm sorry, let me go back here, type an integer. We're taking a square root of a fraction there. That's not going to be an integer. Or a decimal rounded to the nearest tenth as needed. All right, so if we take our lovely calculators here, and we tell it square root of 25 divided by 3, and we just force the decimal approximation by hitting Control first and then Enter. And I'm sorry, I have my calculator here set up for the pre-calculus classes that we always go to 3 decimal places on the AP exam. That'll work enough for us here, but hold on. Let's not get overly enthusiastic. 2.887 is half of our base. The question asked for the length of the sides of the tent, didn't it? What is a side length of the triangle? Okay, so our lovely triangular tent. So that simply means here, we're going to go back, we're going to multiply that by 2, and then we're going to round that off and say it's about 5.8 feet. Okay. And then 16, again, another Pythagorean theorem problem here. For a crane to lift the beam shown at the right, the beam and the 2 support cables must form an isosceles triangle where the height is h. If the distance between the cables along the beam is 18 feet and the height h is 8 feet, what's the total length of the 2 cables? Well, I would argue it's a lovely picture. I need a better look at the triangles. So I'm just going to approximate an isosceles triangle here. And then Put in the height. Again, the height always has to be measured so it's perpendicular to one side. In this case, we're told that the height is 8 feet. And the distance between the cables along the beam is 18 feet. Well, again, this height has to be an angle bisector. It's a multitasker. It's a perpendicular bisector. So that means this side is 9 and this side is 9. So now we're looking for the length of our hypotenuse. So we would write 8 squared plus 9 squared is equal to c squared. Don't feel like typing extra things here. So again, I've got the square root ready to go here. I could type in 145, but I could also, if I hit Control and then adjacent to the Enter button, there's that negative button, not to be confused with the subtraction key. Notice there, again, color-coded in blue. I just insert the answer, and again, force the decimal approximation. So that one cable going from the beam to the top where it hooks on to the, well, the hook for the crane, that's, again, just a little bit more than 144, so that length there is just a little bit more than 12, but they asked for the total length of the two cables. No big deal. We multiply that by 2. Then we round it off. So this then would be about 24.1 feet of cable. All right, so that was some of the highlights there. Again, lots of measurements that we should be able to figure out for isosceles triangles. Anything that's true for isosceles has to automatically be also true for equilateral triangles. And again, once you put in that one symmetry line, once you put in the perpendicular bisector of the base is also going to be the bisector of the vertex angle. We get right triangles, Pythagorean theorem all over the place. All right, so I hope that helped, and I'll talk to you guys later.